Welcome to the channel, guys. Today we're talking about CVE-2022-26923, and this vulnerability is dangerous. It allows attackers to actually pretty much escalate into domain administrator taking over the whole domain. It's apparently abusing Active Directory certificate services, and they are complex, I know. That's why I made a timestamps for that video and it's divided into several parts. First, we're gonna go ahead, explain the theory behind the exploit, behind the core vulnerability, and then we're gonna move on into the practical labs for TryHackMe. And I have to say massive thanks to them because they managed to create and push that lab in no time, so everyone can just hop and test the exploit. If you enjoy the content, make sure to like that video and timestamps down there. Let's go. Alright, so we're starting with 2 blog posts and 1 white paper. The first one is being from SpectreOps, which is the guys who came up with the exploit itself, the exploit procedure with tools like Certify and Rubeus, and they are the guys who actually found the misconfigurations and the vulnerabilities there. They have that blog post which summarizes all the things they have actually found, but if you want to see all the in detail analysis, you can navigate to their white paper, and I'm gonna have all the links in my description so you can find there. The next blog post I want to look over is that from Oliver Riak, which is apparently the guy who made the Certify POC. So we have what to discuss. Let's start. Alright, let's start with the following image explaining what is ADTS and the process of obtaining certificates. So when we're talking about ADTS, you have to know that ADTS is not by default configured inside domains, so not all organizations are using it, but if the one is using it, there's a chance it can be using a misconfigured and vulnerable templates for that. Now I need to mention that certificates inside Windows Active Directory are different from the website. Now here the certificate is making the connection secure, and it's actually mitigating vulnerability like man in the middle and so on, and that's its only purpose. While in the Windows it can be used for many things, but the one we want to look at is authentication. So yes, certificates can perform authentication. Now let's talk about the procedures and the steps that a user can obtain a certificate. We have one: client, user, or computer. This is completely important to know that computers still can request certificate, not only users but computer objects. Generate a public private key pair, and it sends a CSR. What is a CSR? It's certificate signing request. So pretty much this is an easy process of a user or computer to obtain a certificate. So it sends the CSR here, then the enterprise CS server goes there, check the certificate. Does certificate template exist? Are the settings in the CSR role by certificate template? Is the user allowed to enroll for a certificate? So what happens now is, on that server, which is most likely the domain controller, when a CSR comes in, it's gonna go ahead and see its available templates, because the domain CA, I mean the ADTS service, is using a bunch of templates based upon it knows on where to give certificates, who to approve, who to discard, and so on. So it go ahead, comes the CSR, it tries to check the available templates to see if that conditions are met, and if so, CA generates a certificate and signs it with its private key and sends it back. The client stores certificate in Windows Certificate Store and uses it to perform actions allowed by certificate authentication, code signing, and so on and so on and so on. This is in a nutshell the steps for every user or computer to generate a certificate. So let's take a moment to explain where and how this can be vulnerable. Let's start by explaining a different term so you are more comfortable with. So let's start with the PKI, public key infrastructure. It's a system to manage certificates / public key encryption. We have ADTS, which is Active Directory Certificate Services, which is a Microsoft PKI implementation. So that thing is responsible for managing all the public key certificates, encryptions, and so on. We have the CA, Certificate Authority, PKI server that issues the certificate. So that instance right here, that service, is actually signing the CSRs and are pushing certificates. We have Enterprise CA integrated with AD, as opposed to a standalone CA, other certificates template, So that thing is designed for managing to multiple Active Directories, domains, forests, and so on. It can use templates for different kind of systems. Certificate template, a collection of settings and policies that defines the content of certificate issued by enterprise CA. So this is the tricky part, and this is where it becomes dangerous, and we're gonna understand why in just a minute. Then we have a CSR, certificate signing request, we mentioned it already. And then we have the EKU, extended or exchanged key usage. One or more object identifies that define how a certificate can be used. So that here means what a certificate can perform, either authentication, code sign, and so on. That's the thing that says, hey, that certificate on that user can actually authenticate, and so on. So let's start with the template and see why it can be dangerous. On the previous image we saw, we can see that CSR contains a template, right? So it has a template of sending a CSR, so we need to populate a few values like the template name, subject, and AQ. So we can, for example, say that we are using the user template for the subject corp/user, and EQ I can code sign with that certificate. Then the CA is gonna go here and it says, yeah, this user should go sign a code. Then it can the approved properties, groups, and permissions, and so on. So yeah, I'm gonna instantiate the certificate, no worries. The problem occurs whenever a user can supply fake template and tricking the CA server to sign and push fake certificates. I'm not meaning fake, I mean misconfigured, because the user, if there is a vulnerable template, and that's what tools like Certify are scanning for, if there are vulnerable template, a user can request a certificate with the CSR, and that vulnerable template itself is going to say, that user is administrator, or that user can authenticate as an administrator, and you get the idea. So now let's understand what exactly is vulnerable with the template and how we can misuse it. So the few things we need to have for a template to be vulnerable are actually three. So we need a permissions, which is being allow in row or allow full control permission. If of course we have full control permission, we can easily go ahead and do whatever we want with the certificates. We can modify, and pretty much we're the administrator already. But in most cases, we can encounter allow in row. So a user must have the ability to enroll itself a certificate. The next step is to have a client authentication. So we must, I say must, have the AQ for authentication. That way we can use that certificate for authentication, and if we are missing any of the steps or requirements, I can say 1, 2, or 3, we are not gonna able to exploit the vulnerability. But if all the three are met, we can simply become domain admins in few clicks or commands. The third step or requirement, is to actually have client specify SAN. So we need the flag city, flag, and row supply subject, and that means we can supply our own SAN instead of relying the default ones that the CA server pushes. And why that's important is because we can supply the SAN of each subject alternative name. If you are not sure about the terminology, we can supply the SAN of any machine or any user of our choice. And that way the CA server, if the template is vulnerable, of course, is gonna push a certificate relevant to that user or machine, which is gonna result in domain takeover. Let's actually go ahead and analyze the environment. We have two TryHackMe Labs. First one is being AD certificate templates, and this is just a misconfigured Active Directory with a lot of certificate templates. And the second one is being CVE-2022-26923, and that's the whole CVE part here. So we're gonna take the both labs. This here we're gonna use Certify and Rubeus to go ahead and change the administrator password, and here we're gonna use to like Certify to go ahead and exploit the vulnerability, just to see you guys how it's actually working. So the first lab, the idea is to go ahead and change the domain password, and there I'm not sure if I can use the Certify CVE here, but I think it's a good idea to demonstrate how Certify works as well. So the tools we're gonna need for that is Certify, which is that one, and I can say again that all the links you see in the video are gonna be posted down in the comments. This is the Certify, and yes, it has no releases, it has no executables, you have to compile it yourself. And if you are not comfortable with compiling it yourself, you can search for Certify precompiled, maybe compiled binaries, yeah, that's it. So here we have certify.exe and rubeus.exe, and that's the thing we're gonna need for that demo. So now let's just start with the lab. I have connected to my VPN, and then let's start with the first lab, start machine, and roll it up. All right, let's take a minute to create a directory and organize our environment. mkdir adct for AD certificate templates, cd adct, and let's see what we have. We have username, password, and domain. So let's first copy the IP address and move it into our sudo vim etc hosts. That way all the resolution is gonna be forward to that IP address. Let's wait 30 seconds. So now we're gonna demonstrate how the theory works, and keep in mind that that was really a brief overview. If you want to learn more in details, I highly recommend to go with the white paper. And keep in mind that there are a bunch of attacks. I mean, that's not just that one. We have, if you scroll down the SpectreOps blog post, we can see that there's actually 8 kind of attacks. Misconfigure certificate templates EC11, ESC2, ESC3, up to ESC7 or 8. That's the wrap up. So we have 8 kind of attacks, and every attack is kind of different. For example, the ESC8 is anti-RAM relay on ADCS HTTP endpoints. So it's abusing different kind of vulnerabilities. Now we are talking about the main one, which is ESC1, where we can actually go ahead and request a certificate as a different user, specify different SAN. That's the way we're gonna do now. That's the exploit we're gonna do. So the idea is to send a CSR saying that, hey, we have that user, give us a certificate. The CA is gonna trick us. We're gonna trick the CA into signing that certificate because the template itself is vulnerable. And then the CA is gonna say, all right, administrator, here's your certificate. And that way we can log in, change the domain user's password, change the admin password, and so on. So let's see if the lab's been loaded, and it is. So copy the IP address, go here, type sudo, sorry, paste the IP address and type the domain. So paste it here, all right. And now let's try to sh into the box. So sh thm, right, and the domain, yes, and the password was password1, yeah. So the whole vulnerabilities and the whole blog post and things are at the point of where you can actually go ahead and log in into a compromised system. So we are not talking about all the things that happened before that. For example, did you exploit any vulnerability? How did you get in there? So if it was a phishing attack and so on. We are talking about from the point of exploiting and getting into a box and so on. So we are talking all about breach escalation, and the bot traps are designed just for that. So that's why they gave you an SH key. Now the first step is to actually go ahead into cdc, and now let's open a PowerShell and cd tmh tools. Yeah, so here we have rubeus.exe, and the map of TryHackMe actually demonstrate how you can request a malicious certificate template by yourself and how you can enumerate it. So for example, we need to go to MMC. So first step is obviously to go ahead and run remote desktop, which I'm not a big fan of, because if you compromise the system, and the last thing you would do is to actually go ahead, open remote desktop, and the user is gonna say, what is actually going on? You're gonna get caught immediately. So what I like doing is always prefer the DIY variants. So what we're gonna do now is to download that Certify compile thing there, certify.exe, download it, save file, and copy it here. So I'm gonna split my pane and type move downwards certify.exe to here, and now do Python -m http.server 80 and just download the executable. Let's just do who am I. So we are THM user inside, and let's just download the file. Invoke web request http 10.9.0.247. I'm watching my IP address here, and now certify.txt into out file certify.txt. Not sure why, but the terminal got blocked up. Oh, it's back again. Let's see. Do I have internet connection issues? Maybe. That's strange. Alright. So it looks like it downloaded successfully, and keep in mind that this app do not have connection to the wild. So if you try to download Certify directly from GitHub, it's not gonna work. So that's why I just downloaded it to my box and then through the VPN to that system. So we have certify.txt. If we run the tool, we have the bunch of commands it requires, and pretty much they say what it can do. And what we want to look for is that certify.txt find vulnerable. So certify.txt find, or actually find without a slash, vulnerable. Maybe that was syntax, and it is. So now the first step is to actually certify goes and enumerates the CA server, and then tries to seek for vulnerable templates. And by vulnerable templates, I mean that the template should have the ability of enrollment, authentication AQI, and to change the SAN name, the one we described right there. Not here. Yeah, that here. So we need to, have the permission for enrollment. We need to have the AQI for authentication. Then we need to specify custom SAN. And the certified thing is going and testing for every template for that conditions. If it's met, we have a vulnerable template, which is the case now. So the next step is to actually go ahead and request a certificate, and that's done with the Certify as well. Then after we request a certificate, we need to convert it into PEM, and then we can use to authenticate into the box. So let's try and request certificate using that template there. So we need to keep note of the template, which is being user request. Let's request certificate, certify.txt, request. Let's go ahead and copy the CA name. /CA, paste the CA name, / what was it? Template equals to, what was the template name? User request. Then we have out equals to administrator. Let's see. So we are trying to request a certificate for the administrator user. Not sure if I need to specify out name or just out, but let's see. If the things crash, we need to specify out name. We have the request ID, which is nice. And we have something which looks like a certificate, and the good thing is that in the first version of the tools they have to separate that things. Now it's way easier just to go ahead, grab it, paste it, and we have the whole file. So we can see that it grabbed the certificate. Let's look at the output. Current user context, so we didn't specify the administrator, which is bad. So let's try with out name, I believe was the syntax. Out name administrator, and now we have the administrator. So we missed that point, so we're gonna get a different certificate which is gonna perform different actions, have more privileges, I mean. So the syntax is out name. Maybe they didn't provide any type of data if any of the option error message if any of the options is incorrect, but you know, that's why we need to watch carefully the output. So we have the certificate. Let's go ahead and copy it using tmux. Go here, type space, and just move up. All right. Copy the certificate, enter, then go to my new pane, close the server, vim serve.pem. It's in PEM format. Set paste and type Ctrl-A and the bracket. All right. Now I have my certificate there. What I'm going to do now is copy the OpenSL command here, paste it in, I'm not going to provide any kind of password, and we can see that we have two different certificates. The PEM file is the one we got from the output, and the PFX file is the one we created. So by default, Windows is generally working better with PFX files, and that's why we need to manually go ahead and convert it. So we need to now, the next step is to actually go ahead and request a ticket for it, and then we can use that ticket in order to authenticate and do stuff. That's where we use the tool called Rubeus, and the first step is to actually, again, download our certificate. So Python, HTTP server, go ahead to Rubeus, to the Windows, invoke web request HTTP 10.9.0.247/serve.pfx, and keep in mind that it's designed for administrator user. And I forgot to specify out file. So out file, what was it? Serve.pfx. All right, and now let's talk about Rubeus. My bad. Now with Rubeus, the point is that we can do a lot of things. So we can do pass the ticket attacks. We can literally get the tickets. We can change users' passwords and so on. So the first step is to do ask TGT. Then we need to specify the user we want to ask. So user administrator, and then specify /cert equals to c thm tools and serve.pfx. We must apply a password or a certificate. Alright, it's not cert, it's certificate. Certificate. So we have asked for TGT and we have an error. Not sure why. Let's see. After a lot of debugging, I came to the point that you always need to test your tools multiple times. And yes, in the moment I read a lot of stuff with the supplied DN name and so on. The moment I try it with the same commands, it resulted different output. So that's the moral of the story, guys. Always test your tools multiple times. So let's go ahead, refresh the environment, remove serve.pfx. We need to remove the certifications here as well. All right, and now let's do the process once again. Certify.exe, find vulnerable. I forgot about the template name, so I need to have it again. Let's copy the CA while it's loading. All right, now it's okay, and let's do it. Certify.exe request /ca equals to that. All right, now then we need to specify out name equals to administrator, and we need to specify template equals to, what was it? User request. Paste it in. We have the certificate request 19. Now let's go ahead and copy the whole certificate. Maybe I have done something wrong while copying it, but not sure. And copy it like that. All right. Now go here, vim serve.pem, set paste, insert, paste it in. Now let's convert it, not here, here. Copy the command, convert it, no password, and host a Python server. I'm gonna download it here, invoke web request HTTP 10.9.0.247/serve.pfx, and out file serve.pfx. All right. We have it now. Now let's try Rubeus.exe ask TGT. We have, not sure if I needed to specify the domain name or just the administrative user and certificate. Let's try user administrator and certificate equals to serve.pfx. And now we have it. So no tool is being perfect, although some of them like that are doing decent job and making the automated things, the manual things automated, but always test your tools perfectly. As you saw, I have lost a lot of time debugging, but that's the life of the pen tester. So we need to copy the ticket itself like that. Alright, go here, vim ticket, set paste, paste it in. Now let's remove the new lines, %s, new lines, or first the spaces basically. Alright, and now %s, new line, G, maybe that was the syntax, and I think it is. So let's cat ticket, alright, cat ticket, copy it. Now what we need to do is to use the thing called pass the ticket, PTT, which can be used at Rubeus, and whenever we do that, we can use that ticket to perform actions like password change and so on. For that case, I'm gonna go ahead and try to authenticate to the administrative user to see if the password is actually wrong, and then we're gonna run the command and see that that password is changed. So SMB map, we have the command predefined here from my debugging session. Run the command authentication error. Go to rubeus.exe ptt /ticket and paste the ticket from here. Paste it in, and the ticket is imported successfully. Now the next step we have to do is to run the Rubeus to password change, and we pretty much can escalate to domain admin. Let's do this. So rubeus.exe change, what was the syntax? Change POE? Not sure. Let's check that. Where was it? All right. Yeah, we need to type change password, new, let's try change me123, then we need the DC, I believe, yeah. This is gonna woundc.wooner.eruka.com. What's the syntax? wooner.eruka.com. Alright, then we need the target user. Equals to administrator, and the ticket itself. Ticket slash, copy it once again, paste it in. We have, alright, so we need to specify the domain and the user. All the way up. Type owner.eruka.com / administrator and the password change success. Now let's go here and SMB map into the very same thing, and that time we can confirm the administrator password has been changed successfully. That was the life of TryHackMe by abusing the certificate templates, and now we can hop up into the CVE lab to demonstrate how Certify is working, and we're gonna escalate into slightly different manner using Python tools and remote engagement. So let's go. Let's take a moment to talk about the lab, and I can say once again that all the links gonna be in the description. So what's happened now and why is different from the previous example? So we have, in the previous example, what we did is to manually go ahead and abuse the misconfigured template using Certify. In the lab itself, it's shown how to abuse it manually with remote desktop connection, but we did it with Certify. Then we generate a certificate. That certificate we convert into PFX, then we import it to Rubeus, and that way we was able to, by importing it to the system, we was able to change the password and perform authentication and so on. Now we are using a tool called Certify, which is used for, let's say, range attacks, and the kind of it works is slightly different because here we want to firstly have to create a machine. So the commands are quite simple with the Certify, but it's based in Python and the syntax is slightly different. So we first can go ahead and generate a certificate for that user. Then we need to log in into that account and create a machine itself. And why a machine? Well, this is because we have something like UPN. Alright, so we have user principal name and SAN we discussed previously. So by having a machine, and this is done for most of the domain controllers because many organizations has the policies, or I can say most of the organization has the policies of allowing users into joining some device into the domain, for example, laptop, PC, something like that. And that's why any user can create a machine. And while a machine is being made, it's way easier to actually trick a certificate template to perform what we want. So if we request a certificate template from a machine and not from a user, then we can trick the CA into actually giving us back the certificate we want. If we want to take a closer look, we have that, where was it exactly? User principal name UPNs with user account will be embedded in the SAN. That can be used for identification. Since UPNs must be unique, and we usually do not have the ability to modify UPN, we cannot leverage this template. So that's why we need to create a machine, because there we can. Alright, what I have done so far is to I started the lab myself, copy the IP address, went to cat etc host, pasted the IP address here, and also the other DN names which can be found in the very bottom of the lab itself. Then I went to Certify and clone it to my directory. I cd to Certify, and to install it you can use with sudo python 3 step.py install, and that's going to install the Certify for your system. Now let's take the process, and which is actually displayed here really well. Not the template, we need the explained. Yeah, so we need to compromise credentials of all previous AD user, then we use this credential to enroll a new host on the domain, alter the DNS host name, attribute to computer AD object that has no of privileged host, such as domain computer, remove the SPN attribute to bypass the unique SPN config issue, request a machine certificate using the default template, and perform key-browser authentication. These are pretty much the steps, so let's go ahead and do them. So let's go here, and we don't need it anymore, so let's try to directly request certificate. So certify request lunar.com/thm and the password, which is given us from the beginning right here. Then we specify LunarDC, which is the domain controller, lunar.evoco.com, we specify the CA server, which is the same as the domain controller, and then the template is being user. After that command, a certificate is gonna generate, and we can use certify auth command, which is gonna try to authenticate us with that certificate. So we have the NetBIOS connection, and in that case, keep in mind that all the things in TryHackMe Hack the Box are cloud-based, so there's a chance cloud is not working as it should, so we should be patient and run the command again. Of course, following the example from the previous one where I debugged live for like 40 minutes and so. Never mind, so we are back and we have certificate. So we can try certify auth, and what was syntax? I need to specify the pfx format and then thm.pfx. Maybe that's all it is. Maybe that's it, yeah. So it's trying to get the TGT, but keep in mind that now we are trying to get the TGT and authenticate. For that user, we request the certificate. To bypass that and to actually perform the CVE, we need to actually log in and install a new computer and then change it. So we have the NTLM hash, so it automatically tries to display the NT value, NT hash, sorry, not NTLM. So let's proceed to the exploitation, and let's just go ahead and create a new machine. So that for that to happen, we're gonna use inpacket. So inpacket add computer like that. Then we need again the same syntax we have there, and that's what I meant by the tools are inpacket supportive. And not sure if we need to specify the DC again there. We're talking about inpacket. All right, now we need the method to be LDAP s, to not conform with the LDAP. Then we need computer name to be, let's say, well, user is THM, TryHackMe, THM, PC. And then we're gonna need the computer pass, which is gonna be as again password 1 as the very same password as the user. Let's run that command, and we successfully add the machine. So now let's split up our pane, and now let's sh into that box. So thm, what was the domain? owner.com. Now password 1. Go to PowerShell. And now let's see the available computers that we managed to add. So get AD computer. Do we have tab out complete? Yes, we have. And if you have a shell like that, it's a really nice thing to have. So we need to filter. It could not get all of them. So let's try to filter it by specifying the HMPC. Alright, so we have the properties. User principal name is being empty. Then we have DNS hostname. As you can see, it points out to thmpc.owner.heroku.com. So what we need to do is to actually go ahead and change the values of DNS hostname, but for that to happen, we need to actually fetch the UPN value there. So this is done with the command set AD computer thmpc service principal names equals to nothing. Then we need to set AD computer thmpc. Now we need to type DNS hostname to be equals to woundc owner.com. Alright, and now when we get the computer again, we can see that the DNS is being changed. What's gonna happen now, we're gonna request with Certify a request for that computer, and since we manually changed this DNS to point to the domain controller, we're gonna request its certificate, so its hash. We're gonna get the hash of the domain. So let's go here, request change the, not the add computer, we want to request, yeah. So we need to template to change to machine. Then we need to type, instead of THM, THM PC, and type the $sign, and that's how Windows defines a PC there. And by running that command, we should request certificate for the domain. So let's wait and see if I have mistyped something. We have again that net bias connection. We need to wait a little bit. Run that again simply. Oh, come on. And we have it. Now, this time we can see that instead of our user, we have certificate called woundc.pfx, which apparently is the domain controller certificate. So that way we tricked the CA server to push certificate that is not meant for us, but for the domain itself. So now having that certificate, the thing is that the whole environment and domain controller thinks that we are the domain admins. And the point is that this is really resistant, because in a way that if our passwords got changed, the certificate is still valid and we can authenticate with it. So let's try certify out pfx woundc.pfx. We can see it's using principal woundc owner.com. So we are really querying the domain PC there. And we have the empty hash. Let's copy it and try in packet secret dump. What was the syntax? In packet secrets dump. So after a short debugging session, I managed to find out that the issue was the forward slash. Yes, you heard me right. I'm gonna close the session now. That was the command we previously ran. It resulted in SMB fail error, and now I run the same command with a normal slash, and as you can see, we can dump all the available hashes there. So yeah, it's kind of annoying and the syntax is kind of strange to me. I've struggled a lot to remember where to use forward slash and when to use the normal slash. And as you can see, when you have two similar tools like Certify and Certify, you have a lot of errors when doing the right syntax, but we managed to find a way. Thanks for watching, guys. I hope you enjoyed and learned something new. And if you stick to that point on the video, you rock and you're amazing. That was tough, and there was a lot of materials, and we know that I'm bad at remembering syntax for AD and domains, but you know, there's always times to learn, and I'm gonna upgrade myself. I hope you learned something new, guys. If that's the case, make sure to like that video, subscribe to our channel to see more of the content like that, and follow me on Twitter. If you have any ideas about CVE future video, make sure to pop them into the comments below. So, see you right in the next one.